guys, this is Mrs. Bolin with your notes for 10.1. We're going to start with the answers to the warm-up. So just as a reminder from our last chapter, we're going to go ahead and multiply the big numbers here and get 15. Then we're going to say if we have two x's and one more x, then altogether we have three x's that are being multiplied by themselves. So we use exponent 3. We've got one y there, so we just kind of leave that at the end. And that is our answer for the first one. Question number 2, we're going to do the same thing, but we're going to divide by the big numbers first. So 12 divided by 4 is 3. And then we ask ourselves, where are there more x's in the top or the bottom? Because remember, if I write those out, I'd have 5 in the top, 2 in the bottom. So 2 of them would cancel off, and I would still be left with 3 x's up in the top being multiplied by themselves. So that's why I'm using the exponent 3. Question number 3, if we are solving a two-step equation, just some review here from Unit 1, we would start by getting rid of anything that's being added or subtracted on the side where the letter is. So the opposite of plus 6 is subtract 6. That's the inverse operation to cancel it out. So we have negative 4x, and then we have negative 16. We're going to divide by negative 4 on both sides because that's the inverse operation of multiply by negative 4. So we get x by itself now is equal to a positive 4. Question number 4, this is just a distribution problem. There's no equal sign, so we're not solving for anything. We're just simplifying it a little bit. So 2 times x is 2x. 2 times 7 is 14. Okay, so we're starting a new unit here about polynomials. So a polynomial just means that we have many terms, okay? It could be a monomial, which is one term, a binomial, which is terms, trinomial, and on and on and on. Usually, if it's more than 3, we just say it's a polynomial with however many terms, okay? We also like to put polynomials in standard form. That's where we start with the highest exponent, and then the exponents decrease from left to right. And then the coefficient of the first term is what's called the leading coefficient. Remember, the coefficient is just that big number that's stuck to the letters. Okie dokie. So we're going to go ahead and go through some problems here. So here's our practice. We're going to write this in standard form. So we start with the highest exponent. So we're going to write 3p squared. And then the only other term we have there is that 7. That is in standard form, and we're going to classify it by the number of terms. This is a binomial because it has 2 terms, and I'll kind of highlight those, underline them for you. Those are the 2 terms. Terms are separated by pluses and minuses, okay? So even though that 3 and the p squared are different things, they're all stuck together, so that's considered one term. So we have 2 terms here. This is a binomial. For question 2, we're going to start with the highest exponent and work our way down. Okay, so we have 2c to the 4. The next highest exponent would be that squared. So we have plus 6c squared. And you're looking for the sign that's stuck to that term. So both of those are positive, so they both are positive when I rewrite it. And then this c has an exponent of 1. Even though there's no exponent there, we know if we have 1c, that we have an exponent of 1. We also have a coefficient of 1. This one is negative, so when I rewrite it, I need to have a negative stuck to it. So I have 3 terms here because I just look and I see how many things are being separated by pluses and minuses. So because there's 3 terms, this would be a trinomial. Okay. So now we're going to actually simplify some expressions, and we're going to combine like terms. So like terms are any numbers that have the same letter with the same exponent. So looking at this first one, I have 4x and 6x. Well, this is a negative 4x, so it would kind of subtract from the 6x's when I combine them. So I would have 2x, and then I'm going to look and see what I have left over. I've got a plus 9 and a minus 14. And when I'm adding those up, positives and negatives cancel each other. So I just say, well, what do I have more of and by how many? So we have more negatives, so our answer will be negative. And then I've got 5 extra. So our whole answer there is 2x minus 5. And we did write it in standard form because we started with the exponent the highest exponent, which would just be a 1, and then we ended with a constant. A constant is just a number that doesn't have a letter stuck to it. Okay, so now we're going to do the same thing over here. I'm going to start with the a's. I've got a negative 3a and a positive 7a. And so I'm going to combine those, which gives us 4a. Remember, if the signs are opposite, they cancel each other out. So you ask, what do we have more of and by how many? We have more positives, and there are 4 extra positives than there are negatives. So it would be 4a. Then we're going to look at what we have left over. We have a negative 2 and a positive 5. So that would be a positive 3 because I have 3 extra positives. Okay, so our answer would be 4a plus 3. Now we've got a little bit bigger problems coming up. So instead of just 2 terms, now we have 3 terms that we have to keep lined up. So what you're going to do is you're going to look for the highest exponent in both of them and see if they match up. So we have squared and squared. Well, if I have a positive x squared and a negative x squared, you have to do the sound effects. Those cancel each other out. Okay, so now I'm going to look for the next thing. I've got a positive 3x and a positive 6x. So altogether that makes positive 9x. Then I'm going to look for the next thing, which is a positive 5 and then a minus 4. So if I have 5 and I take away 4, I still have 1 left. So I would write that as a plus 1. And that's my answer. And this all of our answers so far have been binomials. So let's take a look at this next one. So again, I'm going to start with the highest exponent. Here I have a t to the third, and over here I have a t to the third. So I can put those together. So if I have 3 of them and I'm taking away 2 of them, then I have 1 t to the third left. If I only have 1 of them, I do not have to write the 1. If you put it, it's not wrong. It's just not in the most simplified form. So I'm going to leave it off because it's 1 less thing to write. All right, so now I'm going to move to the next thing. I'm going to say, well, I've got a t squared right here. And then I have a 2t squared. So if I have 1t squared and 2 more, then altogether that would make 3t squared. Okay, here's the tricky part, because look what's left. We have a negative 3 and a positive 7t. Those are not like terms. So what I do is I'm looking for standard form. So I went to the third, I went squared. Now I'm going to look to see if we just have a regular t. Well, there is one. It's only over here, so there's nothing else to combine with that. So I'm going to write plus 7t. Then I'm going to say, well, what do I have left? I still have that negative 3, but it doesn't have any t's with it, so there's nothing left to put it together with, so we just write it at the end. Okay, so this answer actually has 4 terms to it. Okay, 1, 2, 3, 4 different little parts that we had to kind of put together in the right order. Standard form means that we start with the highest exponent, 3, 2, 1, 0. Okay, so now we're actually going to go over the odd answers to your homework assignment for tonight. So go ahead and flip over to the next page on page 86. You don't even have to flip, actually, just look on over to there. Move my camera just a little bit for you guys. There we go. Sorry, that takes me so long. Okay, so question number 1 says write the polynomial in standard form and then classify it by the number of terms. So what we're doing is we are looking at the exponent, and I can see that I've got an 11 and a 12. So I'm going to start with the highest one. So I have, and this sign goes with it, you guys. So I have negative w to the 12th. And then I say, well, what do I have left over? And I've got that positive 4w to the 11th. So be really careful to make sure that the sign sticks to it and moves with it wherever we put it. Okay, there's no plus right here, but it's a positive 4. So we want to make sure that we put that plus in there to separate the terms. Okay, this is our final answer here. And then we want to classify it by the number of terms. Well, there's 1, 2. So this is a binomial. Okay. Question number 2, you guys can do on your own. Remember to start with the highest exponent and then go down to the next highest one and then end with the lowest exponent. And then this one has 1, 2, 3 terms, so this would be a trinomial. Okay, so a little hint for question 2 for you. Okay, question number 3 says to simplify each expression and write your answer in standard form. So we are going to start by looking at the highest exponent, which just happens to be plain old x's. So if I have 9 positives and 8 negatives, 8 of them are going to cancel out, and I'm still going to have 1 positive left over. So I'm going to write 1 positive x, which looks like that. You could put a 1 in front, but don't enter in Canvas that way because that would be marked wrong. It is technically correct, but it's not the most simplified way to write your answer. Okay, then the next thing we're going to look for are our plain constants. So I have -12 and +4. So again, 4 of them are going to cancel off because the opposites, a plus and a minus, cancel each other. So I've got 4 of those that are going to cancel off, but I'm still going to have 8 negatives left over. So we're going to write -8. Okay, that is your answer in standard form. Question number 4 is a little bit bigger, but remember, you're going to put like terms together. So anytime there's no number, you can always put a 1 right there. That might help you guys a little bit. 3 negatives and 1 negative makes 4 negatives. So you're just going to go in order, p to the third, p squared, regular p. Okay, we're going to move on down to question number 5. So I'm going to do the same thing. I'm going to start with the highest exponent that I have, and I happen to have one in both sets of parentheses. When we have that plus there, we can kind of just ignore the parentheses. Tomorrow, though, if we have a minus, we're going to learn something new for that. But for right now, pluses, you just ignore it. Put things together that are alike. So if I have 2 n squareds and I take away one of them, then I have 1 n squared left. And again, you don't have to write the 1 because if there's 1 there, it's implied that that has a coefficient of 1. Okay, next I'm going to look at 5 negative n's and 3 negative n's, or you can think of it, subtract 5 and subtract 3. So because they're the same sign, they don't cancel each other out. It kind of makes more of them, right? If I take away 5 and then I take away 3, that's like taking away 8 altogether. Okay, then our next one we're going to look at is this -6 and the +11. Remember, pluses and minuses cancel each other out. If I have 6 little minuses and 11 little pluses, 6 of them are going to cancel. And so I'm going to have some extra pluses there at the end. And so to figure out how many, you just subtract 11, take away 6, and you've got 5 left over. So I'm going to write +5, and that is my final answer. So looking at problem 6, I'm not going to do this one for you, but I'll get you started. So remember, you're going to start with the highest exponent. So we'll do those first, and they don't cancel. They're both positive. 3 + 3 is 6. Okay, then you're going to go to the next highest, which would be the g's. And then that 4 has nothing to add with it, so you just write the +4 at the end. Okay, so we're going to move on to question number 7. So for question number 7, we are going to start with the highest exponent first. So we've got 9r squared, and we're going to put that with the 3r squared, which makes 12r squared. Then we're going to go to the next one, and we've got +4r and take away 3r. So 3 of them are going to cancel. Pluses and minuses cancel, right? They're inverse operations on each other. And so we still have 1 positive left over. So I've got 1 positive r left over. So we write the r there. We do not need the 1. Okay. And then I look and I say, well, what is left that I haven't used yet? Just that -7. So I'm going to put a -7 there at the end. Okay. Excuse me. If you look at question number 8, it says describe and correct the error. So I'm not going to give anything away, but I'm going to give you guys a hint and see, oh, those ones look like they put like terms. Those ones are like terms, but here's a question. Are those like terms? Can you put a x squared together with a regular x and just add them up or subtract them? You cannot. So see if you can figure out what their mistake was and what the right answer should be. So that's it for your 10.1 notes, and I will see you guys next time.